Another video on the playlist of Leetcode solutions, and today we would be looking at a very important problem asked by Amazon and Google. And the question name is number of islands. It has pretty much over 5.4k likes on Leetcode, and it's a very conceptual question. So let's get on to the question. So given a 2D grid of map of ones, which represents land, and zeros, which represents water, count the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. So let me make the question a little clear for you. So let's say I have been given a matrix containing zeros and ones, where all the zeros are basically water. So let me mark them as water. So I'm using my right. So all the zeros are water, and I can assume that all the edges are also surrounded by water. So that's why every edge, so basically this particular part that I have drawn, this is also water. So the matrix is there imbibed in inside a water body, let's assume. So all around it's water. So basically all around, whatever it's there, all around is water, correct? So this is the assumption that I can take given in the question. Okay, now the ones are land. So these ones that you see, these ones, these are pieces of land, correct? These, then this one, then this one, this particular one, and these ones, these all are pieces of lands. Now if an island is defined by a piece of land which is surrounded by water on all sides. So basically if I go here at this particular one, let's assume I'm here, right? So this is an island. Why this is an island? Because it is surrounded by water on its all sides. Now one thing that needs to be very clear is that I cannot take these two land masses and group them together, because I cannot take diagonal land masses. It's pretty much given clearly in the question that the land masses are connected horizontally and vertically. So an island is formed by connecting adjacent lands horizontally or vertically, correct? So if I see, if this is an island, so basically this would be surrounded by water on all the four sides. So yeah, that's pretty much it. It's surrounded by water on all the four sides. So this becomes an island. Again, this particular thing, it's also surrounded by water on all the four sides. This becomes an island. This also becomes an island, correct? And this particular thing, the L-shaped, this also becomes an island. So in how many islands do I have? I have 1, 2, 3, 4 and 5 islands, right? 1, 2, 3, 4, 5, correct? So I have 5 number of islands in this whole system of water and land. So this is what I need to find. So how can we approach this problem? One thing that I need to be pretty clear about is anywhere where there is not a 1 is water everywhere, correct? So water is present everywhere where there is not any land. So I don't exclusively need to check for the water, but I need to exclusively check for which are the lands that are present. So let's say I ponder upon this one, okay? Let's say I ponder upon this one. So this one is a piece of land. So I have discovered one island, but have I discovered the whole island yet? No. So I need to discover the whole island. The idea behind discovering the whole island is basically, let's say I discovered this particular land and I term it that it's an island. Now let's say in the next iteration, let's say I discover this particular land and I also term it an island. So basically this is wrong. because both of them are not separate islands and they should not be counted separately. They are a part of a bigger island which is formed by this connection of this S-shaped connection, correct? So for any landmass that I have found so far, I need to see what is the extent of that landmass, what is the extent of that island, correct? So let's say I start scanning my matrix from this 0 0 position, and I found one over here. Okay, so once I found a one, I will mark all the ones. I'll discover all the ones that are connected with this one either directly or indirectly, so that I discover this whole S-shaped island that I have, correct? So this is one, so I'll increment my count. Let's say I have a count variable, so I'll increment my count by 1 because one whole island has been discovered, correct? So in the next step, after discovering this particular one, the next one that I would be looking at is here, correct, this one. So I'll again mark all its neighbors to form a island, and this count would become 2, right? So similarly, I would visit all the unvisited ones, because let's say I ponder upon this one again. So let's say I ponder upon this one. So initially I pondered upon this one, then I pondered upon this one. So but this won't be taken into consideration, because the moment I ponder upon the first one, so this one would be marked as visited already. So I won't visit the marked islands again. So the landmasses that I have discovered earlier, I would not revisit them again. So again, the unvisited landmass is here, the next landmass. So I'll mark this whole, and I'll increment my basically count was from 2, it becomes 3. So count becomes 3. Now I'll find this. So this particular landmass is not connected to anywhere, so I'll just mark this particular landmass only, and since it's an island, so I'll have my count to be 4. And then I find another one, I mark all of its adjacent ones, and my count becomes 5. So 5 is the answer for this particular problem, for this particular example, right? So it's pretty much clear that the algorithm that I need to keep in mind is kind of a flood fill algorithm, right? So I need to mark, when I discover a 1, so I discover a land, I need to mark all my adjacent land masses that are present, and then I will visit that land masses, the adjacent land masses, and from there again I would need to mark all the other land masses that are adjacent to each other. So think of this sort. Let's say you are discovering a group, right? So let's say there is a big mafia group that's operating in a city, and the police gets hold of one of the members of that mafia group. So that one member of that mafia group will help the police to identify all the other members, so its immediate neighbors. So let's say I am a part of the mafia group and I don't have a direct interaction with the person that is being caught, but I have a mutual friend. So this mutual friend is basically nothing but the connection, but the adjacent connection. So I also have a mutual and he also has a mutual. So basically if I say this particular one, this is a mutual friend of this one and this one, since they are not directly connected to each other, right? So if I discover one person, I would discover the whole gang, because one person will discover its immediate neighbors, those immediate neighbors will again discover their immediate neighbors, and this way I can fill up the whole gang, right? So it's kind of a flood fill algorithm. Now people also call them a BFS algorithm, but it's not very name specific, right? So breadth first search is just a method that's applied on a graph to traverse the nodes, but you can also go with the flood fill algorithm thing. It's also a legit name. And one thing I think that's pretty much clear to you is, since I am passing on my task of finding my neighbors to my next neighbor, and they are passing this task to their next neighbor, so basically it's a form of recursion. So the algorithm paradigm that we would be using is recursion, and The algorithm's name is, you can call it BFS or you can call it a flood fill algorithm, right? So let's get on to the problem. So basically I'll have count equals 0, and at the last whatever happens I'll return count. Correct? Yes, I'll have count equals to 0. And also one thing that needs to be sorted over here is, how do I mark one element that it has been visited? So since this is a character array, let's mark an element that has been visited by maybe a cross symbol or maybe a star symbol, right? So let's say I have this particular island. Let me, yeah, so let's say I have visited this particular area, I have pondered upon this particular island, I'll cross it and I'll see whether different islands are present or not. When I find here, I'll again cross it, I'll cross this much, I'll cross here also, because these land masses are all discovered. So let's say I use the character star, correct, for denoting that that particular island has been visited. So the next time I find a 1, but if it is marked star already, I won't even check whether I won't even say that this island is a separate island, because I have discovered it previously. So it may be some part or some connected components of a previously identified island, right? So I'll not increment my count. So this problem is a very good problem, and let's jump into it. So what I'll do for int I equals 0, I'll traverse my matrix, right? So one base case that I need to keep in mind is, if my matrix is empty, so I'll straight away and return count is nothing but 0. So if my matrix is not empty, I'll search through my matrix row wise, right? So j equals 0, j less than grid 0 dot size, and j plus plus. I'll search my matrix row wise and I'll see if that particular I comma j, if grid I comma j is equal to 1, right, I will do two things. If it's 1, I will increment my count first. So I have discovered an island, and I'll also need to see the extent of the island. So let's name the function mark extend, correct? So I'll mark the extent, and it would take grid, it would take the initial position, that is I comma j, that the one has been, right, the one has been discovered in. So that's pretty much it. So I don't need to do anything else. So what I need to write here is mark extend. Mark extend does nothing but mark extend modifies this particular grid vector, and it modifies and gives this crosses this stars all over the vector where there is a span of island, right? That's what it does. So I'll not have any return type. I'll pass on this vector. So let's pass on this vector, correct, and I'll have int I and I'll have int j. That's done. So I'll mark my int I comma j. So grid I comma j would basically, I'll do it as star. And now since I have marked, let's assume I'm here, okay, so I have marked this particular cell, right? The next cells that I need to mark are up, right, down and left, but there are a few restrictions. I would visit to that restriction soon. So first let me mark the cells. So I'll call mark extend again over that same grid with the down cell, which is basically nothing but I plus 1 comma j, with okay, so let me copy this stuff. So I need to call it again for 4 other positions, correct? So I plus 1 comma j I would mark for, let's say, I comma j minus 1, which is the left, I comma j plus 1, which is the right, and I minus 1 comma j, which is the up. So let's see the base cases. So if I am here and I need to mark all its adjacent ones, so can I mark this 0? No, because marking 0 is unnecessary, because 0 is not a piece of land, it's water. So I'll not mark this 0. So one base case is when grid of I comma j is 0, right? So maybe I'll write the base cases soon, but just to make you understand, I'll see what are my base cases. Okay, so base case number 1 is basically when my grid of I comma j is equal to 0, then I don't need to mark it anymore, right? So I'll just return. Now the second case is, let's say I am here and I want to mark on the up. So do I have any cell up? No, I don't have any cell up. So basically the base case 2 would be check whether the next I comma j, that wherever I am going to mark next, is valid or not. Otherwise I would get a error, out of bounds error. So this another thing is basically this will be marked right over here. Let's say now this island that has been marked, the green, this island will again mark its neighbor. So while marking its neighbor, will it mark the previous neighbor again? Because it's already been marked, correct? So the third base case is if my grid of I comma j is already marked, so basically it's already visited, then I don't need to visit it again, I'll just return, correct? So these are my 3 base cases. So let's do the base cases. So first base case is when grid of I comma j is equal to 0. So first, before checking even that, let's check whether I and j are within bounds or not. So if I is less than 0 or I is greater than or equal to my total size, so that's grid dot size, or if my j is less than 0, correct, or j is greater than or equal to grid 0 dot size, which is the column, or now the second base case has been checked. Now let's check for the first base case, or grid of I comma j, if it's equal to 0, then I would return, or if my grid of I comma j is equal to star, so star means it's been visited, I won't visit it anymore, I'll just return. I'll tell my function, okay, you don't have to mark all of them, you complete your recursive call, just return from the function, right? So that's what I'll do, and this is pretty much it, surprisingly. So basically I'll do an else maybe. So let's do an else, yeah, and this is pretty much it, right? So let's see whether it runs on some test cases or not. Yeah, okay, it runs on some test cases, and let's see, for example 2. The example 2 is basically 1 1 0 0 0, again 1 1 0 0 0, then 0 0 1, so that's 0 0 1 0 0, and 0 0 0 1 1. Let's run, and it's giving me the right output, so it's 3, and let's submit the code. Okay, so the code is successfully submitted with an efficiency which is greater than 94.30% of all the submitted codes of C++. So that's pretty much good. So I hope it was clear. See you in the next video, and up till then, please like, comment on how I can improve my explanations, and subscribe. Thanks.